Okay, the last of these videos is learning how to name acids. Now, what are acids? Basically, acids are molecules that when we dump them into water, they give off hydrogen ions. So, when we look at, or when we're trying to differentiate whether something is an acid or whether it's an ionic compound, what we can do is we can look for the presence of hydrogen. For the purpose of General Chemistry 1 and Introduction to Chemistry, what you will see is hydrogen is usually written first when you have an acid. So if I have an acid, that hydrogen or hydrogen ion is usually written out front. So that's kind of our indicator that this is an acid. Now, let's see how to name acids. Well, we have two types of acids, and you have to be able to differentiate between the two, because this will kind of tell you how to name the acids. We have a binary acid, and we also have an oxyacid. Now, binary acids are just acids that do not contain oxygen. And oxyacids are acids that contain oxygen. So, when trying to figure out whether you have a binary acid or an oxyacid, first look for the presence of oxygen. So, for example, H, I noted H is out front, so it's an acid. And because it do not contain oxygen, it is a binary acid. Here we have a molecule that has hydrogen written out front, so therefore it's an acid. And here this acid has oxygen in it, so it's an oxyacid. So the first step to figuring this out, as I say, is to figure out, well, do I have a binary acid or an oxyacid? Well, let's go in and figure out how to name them. Well, if I have a binary acid, the rules for naming is different than an oxyacid. For example, here, if I have a binary acid, the first thing I want to do is begin naming using the word hydro. Or maybe I would say prefix instead of name. That may be a little bit more accurate. Begin naming using the prefix hydro. And the second thing you want to do is name the root name. And you're going to end that root name in IC, in ic. You're going to name the root name. And end the name in ic. And the third thing you're going to do is write the second word, which is acid. know there's probably a better way of putting all three of these, or wording all three of these, but this is just a rough video. I'm no, what do you call it, Khan Academy. I don't have all the special technology and all the different things, but this is a rough video to kind of help you with naming. Okay, so we have this binary acid and this is how we name it. So for example, let's take a look at HF. We've already established that that is a binary acid. So I'm going to begin that name using the word or the prefix hydro. So this is hydro. And then I'm going to name the root name and end in ic. So this will be fluoric. And then I'm going to write the second word, which is acid. This is hydrofluoric acid. Hydrofluoric acid. Let's try another one. HCN. HCN doesn't contain oxygen, so therefore it is a binary acid. So we're going to begin naming using the prefix hydro. So this would be hydro, and this is the cyanide group, so it would be cyanic. Cyanic, and we ended in acid. Hydrocyanic acid. So anytime we have a binary acid, this is how we name it. So let's go back. Now what if instead of having a binary acid, we had an oxyacid? How would the naming change? Well, the best way to figure this out is you can use this sort of a, I don't know, it's not even a rhyme. I don't know, kind of a saying maybe that can help you with learning how to name oxyacids. It was icky, and so I write a line under icky. So I ate it. And lighthouse. So for oxyacids, you're going to have a polyatomic ion. And what this means that if the polyatomic ion is 8, we would change the 8 into ic. If the polyatomic ion is ite, we would change the ite into us. So this is how we would know what our suffix would be for our oxyacids. So let's take a look. Let's take a look at HNO3, because we've already established that this was an oxyacid. So in the first rule, and this is the #1 common mistake that most people make, never begin naming using the word hydro. Or the prefix hydro. This is the #1 common mistake. Never ever begin naming oxyacids by using the prefix hydro. So, let's see how to name it. So here, we're gonna look at the polyatomic ion. The polyatomic ion here is called nitrate. So since it's called nitrate, we can go here for how to figure it out. Since it's an 8, we turn it into an ic. This becomes nitric. And then we end it in acid. We don't begin using the word hydro. So this is just nitric acid. Now what if we had HNO2? Well, we would do the same thing. HNO2, we would know because of O, it's an oxy acid. So we're going to figure out, we know we're now going to begin naming using the word hydro. So what we're going to do, this right here is called nitrite. So what we're going to do, this is an ite. So we turn the ite into an us. So this would become nitrous acid. This is nitrous acid. Okay, so then let's take a look at one more example. So here we have oxygen, so therefore it's an oxy acid. We know never to begin naming using the prefix hydro. So let's take a look. Here we have a polyatomic ion, sulfate. This is called sulfate. So since this is an 8, we use this guy here. We change the 8 into an ic. Now, it would make sense, or you would think, well, this is called sulfic acid. But that's actually not how we pronounce it. We actually, the root name for this is sulfur. So we call it sulfuric acid. So it becomes sulfuric acid. Not hydrosulfuric acid, but sulfuric acid because it is an oxy acid. The same thing is with if we had phosphate. It's not phosphic acid, it's phosphoric acid. The root name of it kind of changes from what you would think with the 8. So, now you've learned a little bit about how to differentiate between a binary acid and an oxy acid. Let's kind of put it all together. Let's see if you guys truly remember. So if we take a look at this molecule here, we have HBr. So the first thing I want you guys to do is pause the video. Figure out whether it's a binary acid or an oxy acid. Now, looking at here, this is a binary acid. So therefore, binary acids we begin naming by using the word hydro. So this would be hydro, and the prefix or the root name for this would be brome, and this would be bromic, because all the binary acids end in ic. Hydrobromic acid. Well, Here, I have an acid, and I know I have an acid because hydrogen is written out front. Same thing with here. So here I have an oxygen, so therefore this is an oxyacid. So oxyacid, because it's an oxyacid because it contains oxygen. So I'm going to figure out what's the name of my polyatomic ion. This is phosphite. So if you remember, lighthouse. So it will end in, we will drop the I and in, use us. So this guy right here, because it's an oxyacid, we don't begin naming using the word hydro. So this would be phosphorus acid. Phosphorus acid. Now, I know you would say, well, why did you put OR? But that's just the way that we name it. We don't do phosphorus acid. We do phosphorus acid. So, I think sulfate and phosphates are the only ones you have to really memorize that the root name kind of changes. So this is phosphorus acid. So naming acids is also one of those things that that causes students the most trouble. However, if you use these rules and you can differentiate the types of molecules that you have, you can always name your compound. So you have plenty of worksheets to do. You have a video that you can continue to watch over and over again. So hopefully this helps. All right.